All right, so when we're simplifying radicals with variables or radicals in general, I think of it as a mama's house. So when I talk about a mama's house, right, mama is always going to protect her kids. And depending how many kids are in there, she's only allowing so many out at a time. So if we have a square root or it looks just like a square, she will only let 2 out at a time. If we have a cube root or it has a little 3, she will only let 3 out at a time. Fourth root, she will only allow 4 out at a time, and so on. So if we talk about, okay, say mama's house, and again, the inside here is mama's house, the outside is going to be the outside world. So if we have, say, square root of 4, we break it down into children. Right now, it's a big mama. We want to break her down into children. Square root of 4 is 2 times 2, and because it's a square root, they have to become a unit and they're allowed outside. So 2 are allowed outside at a time, but they become a unit, so it becomes 2. And we know square root of 4 is 2. Let's do square root of 8. So we have square root of 2 times 2 times 2. Okay, she only lets 2 out at a time, so I'll circle these 2. They're a unit, they get to go outside, but there's one lonely one on the inside. They have to stay inside. They do not have a pair, so it becomes 2 square root of 2. Same if I look at 16, square root of 16. I'm going to break it down, okay, because that's Big Mama. You got to break her down into her kids, which is 2 times 2 times 2 times 2. So if you circle each of these 2, they each have a partner to go outside, and yippee, they get to go outside and play. So we're going to have 2 times 2, which equals 4. Now, you know square root of 16 is 4. Square root of 8 you might not know is 2 square root of 2, but you know square root of 4 is 2. So I hope this makes sense. If not, there's other videos that explain how to reduce radicals. Now that we know how to reduce radicals, what if there are variables? That just means Big Mama just got a little bit, not more complicated, she just kind of had some more children. So say if I have square root of 8 times a cubed and b cubed. Why don't we just do that? So if I have square root of 8, this is kind of a Big Mama. So we're going to break her down. 8, okay, breaks down into 2 times 2 times 2. A to the third, or a cubed, means that there's 3 of them, right? So we have a times a times a, and then we have b times b times b. And remember, they're all under the house right now, but they want to go outside and play. So I'm going to circle 2 at a time that can play that are the same. These guys can go outside and play. These guys can go outside, and these ones are going outside. The ones that are left, I have a 2, A, and B. They do not have a twin to go outside and become 1. So I'm going to put the 2 outside, the A outside, and the B outside. And again, when they go outside, they become 1 unit. So I have a 2 times an A times a B. And every time they go outside, you just multiply your outsides with your insides. So I'm going to have a square root left, and who's left on my inside? I have a 2, right? Because we have this 2, and I have an A and a B. So that simplifies to 2AB times square root of 2AB. Now let's do one more, maybe a little bit more complicated. What if I have square root of, let's say, 18, okay, and I have A to the 5th and B to the 6th. Now again, this is a very Big Mama. So I'm going to break 18 down. 18 breaks down into 3 times 3 times 2. It's a prime factor tree. Review prime factor trees if you're not sure how to break 18 down. So then I'm going to have A times A times A times A times A. So I have 5 A's. I have 6 B's. 1, 2, 3, 4. Won't be able to fit it. 5, 6. And when you get the hang of this, you won't need this big of a mama. You'll be able to see that you just take them out in pairs and how many 2's can I fit in. But so far I see I have 3 as a pair, I have A as a pair, another A as a pair, single A, but then I have a B as a pair, another B, and the last B. So the ones I have alone are the 2 and the A. So that they're going to stay inside. Unfortunately, they do not have a twin to go outside, so they are going to stay inside. So on the outside, I have a 3, I have an A, another A, B, a B, a B, square root of 2 times A on the inside. Now, 3 B's can be combined and 2 A's, so I get 3A squared times B cubed, square root of 2 times A. Now, what happens if they're bigger? What happens if there's a larger number? Let's work with a really big mama. So let's work, if I have square root of, we'll just work with an easy 8. The number, you can do prime factorization on your own, but what if we have a to the 40th and b to the 51st? Why not? So if I think about squares, remember, I'm bringing them out in pairs. So I think, how many pairs can I fit in Big Mama to be able to take her out? So I essentially take this and I divide it by 2. If I have any remainders, they stay inside. So 8, I know, okay, breaks down into 3 2s, right? I know 40 divided by 2 is 20. That means there's going to be 20 A's out here and no A's on the inside. They work perfectly. But 50 divided by 2 is going to be 25 and a remainder of 1. So I'm going to have my 1 remainder in here, and I'm going to have 25. Oop, that should be a B. I'm going to have 25 B's on the outside. So you can rearrange them, because now I also have to look at, don't forget your 2's, right? They can come out. And I want to be able to write this as 2a to the 20th, b to the 25th, square root of who's ever left, 2 times b. So when we look at it, we want to be able to break this down into pairs. The easiest way is to divide this by 2. If this is a 3, you're going to divide it by 3 and leave the remainders inside. If it's a 4, divide by 4, leave the remainders inside, and take out your number and put it on the outside.